Okay, I don't know how that little mark got there, but I think it's from the marker I was using earlier. Example 2, solving a system using the substitution method. So solving for a variable and using substitution. So it's 2 steps here. It says solving for a system or solving for a variable, sorry. And then using substitution. So step 1, step 2. Equation A, 3y plus 4x equals 14. Equation B, negative 2x plus y equals negative 3. First thing that I notice is this y by itself, so all I'm going to have to do is solve for y here. So let's look at equation B first. Negative 2x plus y equals negative 3. I want to solve for y so that I can substitute. So it says solve for a variable. I'm solving for y in this case. So plus 2x plus 2x, y equals 2x minus 3. I'm now going to take this whole thing and substitute it back into A, right there, right where I see that y. And substitute the whole thing back into A. You don't want to substitute the equation back into B because it was taken from B. We used B initially. So let's see what the substitution looks like. 3y plus 4x equals 14. Substitute the whole thing for y, where I see the y, so I'm going to say that has parentheses around it. 3 times 2x minus 3 plus 4x equals 14. Distribute. The 3 to each term. I don't know if you can see that. We're going to distribute the 3 to each term. 6x minus 9 plus 4x equals 14. I did not bring down the parentheses because I already distributed. So, collecting like term, 6x plus 4x equals 10x minus 9 equals 14. Solving for x now, so we're saying plus 9, 10x equals 23. This is multiplication, divide both sides by 10. X equals 2.3. Now we're going to solve for y. Let's scoot this over so you can see it. And we can use equation B now. So this was the use of equation A, equation B, going back to it. Solving for y. 3y plus 4 times 2.3 equals 14. Okay, so it's going to be 3y plus 4 times 2.3. Get 2189. And then going to bring the decimal point over 1 equals 14. You can make that a 0 if you like. It's the same thing. We're going to subtract negative 9.2 from both sides. 3y equals 14.0 minus 9.2. Going to give me 4.8. Can you see that? Moving it over so you can see. Divide both sides by 3. Divide both sides by 3. Y equals 4.8 divided by 3. I'm gonna get 1.6. So my solution, sorry about that, is going to be 2.3 comma 1.6. And we got to use decimals. Okay, we're going to do another, now it's your turn. We're doing system and substitution, so we're going to do this together. Please note that these your turns will be now do nows and exit ticket. I should be incorporating those when I return. Okay, so solve the systems by using the substitution method. I definitely want to look at equation B for the first equation to work with, and the reason why I want to do that is because this has a coefficient of 1x, so that would be easy to solve for x there. So let's say we have, bring that over, 1x plus 3y equals negative 7. We're solving for x, so minus 3y, 1x equals negative 3y minus 7. That is a positive coefficient. We are going to take this entire expression and substitute it back all over here where the x is, and I want to put the x into parentheses. So we're substituting for x, and we're going to get everything in terms of x, or in terms of y, excuse me. So you're going to say 6y plus 5, open parentheses, negative 3y minus 7, close parentheses, equals 8. You're going to say distribution. You're distributing the positive 5y into each term. From there, I'm going to get 6y minus 15y minus 35 equals 8. Collecting like terms, negative 9y equals 43. Divide both sides by negative 9 to solve for y on its own. Y equals negative 4.8. Okay, so let's keep on working. Go back to either this equation or that equation, doesn't matter. Let's try this one right now. X equals negative 3, and then substitute for y, negative 4.8 minus 7. Keep on completing PEMDAS. 14.4 minus 7 equals 7.4. My solution is going to be y equals negative 4.8, x equals 7.4. As an ordered pair, it's going to be 7.4 comma negative 4.8. Okay. That is my solution. Now let's talk about the rules or the steps of solving with substitution method. We're going to solve for the variable. It does not matter the variable, and this is only going to happen in one equation. You're going to plug or substitute that equation into another equation. equation. You're going to solve the equation. Going to plug that value into the original equation, or into a original equation. Solve for the other variable. And check your answer. And remember, the answer is an ordered pair. Right, in parentheses. Let's look at this next set of problems. It says systems with infinitely many solutions or no solutions. We went over this in the last video. But yet again, we're going to do substitution. So this is going to go in here, right here. So that right there. So I'm going to say 3.5 times negative 2y plus 4 plus 7y equals 14. Distribute. Negative 7y plus 14 plus 7y equals 14. Lots of 14s. Collect like terms. These two are going to simplify away. So now I have 14 equals 14. And that means it's infinitely many solutions. Alright? So that means that they are the same line. Same lines. That's an N. Now let's look at B. Again, we're going to take this and substitute into y. 3x minus 11 minus 3x equals negative 13. Simplifying. These are going to go away. Negative 11 equals negative 13. This is no solution. Which means that these were also, therefore, these are parallel lines. Which means they have the same slope and different y-intercepts.